Hey everyone, Eric here from Iowa Robot Fighting. Welcome back to So You Want to Build a Combat Robot? This is episode 3. If you are just tuning in and you want to check out the first 2 episodes, since this one's going to be all about prototyping the body or design of the outer structure of your robot, things like that. I'm not going to really be getting into any electronics on this one, and that's really where you need to start to understand what's necessary for combat robotics. So if you'd like to see what came before this and how to really get started, click on the drop down that's appearing right about now, up in the upper right hand corner of your screen, and it should take you to either the first video or the playlist, and then you can get started from scratch. I will warn you, each one of these videos is relatively lengthy, and I touch on all the little basic components that are required for you to be able to really get started in combat robotics. So let's get right into it. Last time I went over the electronics and how to build this little hunk of junk that has since fallen apart. I decided that I was going to use foam core, which is for a single sheet at like a dollar store is literally $1. So I have leftover foam core that we will go ahead and start designing our robot with. But there is one piece of hardware that you're actually going to need to be able to really get started with this, and this is a hot glue gun. You can see I've already got mine kind of warmed up. If you're not familiar with using hot glue guns, you're always going to want to have something to rest it on because it is always going to be dripping molten hot glue. The cheapest ones that you can find at Walmart are like $12. They're no big deal. Glue sticks are like $5 a bag. So once you have one, you're good to go. And ironically, this is a piece of equipment that I actually use at robot competitions on the rare occasion where I've got a torn up piece of plastic, or I want to make sure that electronics are secured down and I'm not worried about having to change them out. You dump a bunch of hot glue in there, smear it through. You're going to burn your finger, but your stuff is going to stay stable in that environment. So I'm betting you're asking, why use foam core to start? And that's mostly for visualization. A lot of my friends and even myself, I don't always prefer to use CAD. When you're first fleshing out your idea, if you're a physical builder and you like to design with your hands, if you like building in Lego and things like that, and you've never touched CAD before, this is where I'd suggest you start. So, hot glue gun, and our old friend, the X-Acto knife. This again can be picked up from Walmart for about, what, $5, $10. So that, and maybe a pen or a pencil, just to get some clean lines. So we'll want to take the electronics that we had from the last episode and pull them off of this board. This is one of the major reasons to start with a foam core prototype, because you need to know that you're incorporating enough space for your electronics. That, for some of our early prototypes, early designs, and even our full-blown combat robots, I think I've got a picture right here of Horns of Jericho, which was Evan's robot, which had so much extra space in it, which meant that we were using a lot more material, adding a lot more weight that wasn't necessary. So you want to try and compact it down to a point where you're not messing with the electronics, the little solder points that were created on the back of your motors when you go to do that. Obviously, I didn't solder these. These are just heat shrunk to it, but you don't want to bend those away. And if it's too tight, you're going to end up jamming that wiring package so hard against those solder points that you could break them. Trust me, I've done it a ton of times. It drives me nuts because you end up losing a $5 to $10 motor at minimum in the process. Okay, so knowing that we're likely going to start with a box, let's go ahead and take a look at fitting this all into a small space, just large enough to fit all the electronics in a loose configuration. As you can see here, I've got almost everything packed into a space that's about that big. And that's probably even larger than what's required. So we can go ahead and kind of cut that out. Now, if you want really clean lines, then you'll want like a ruler or a T-square, or an angle square here, or I think it's called just a square. Don't quote me on that, because I am no construction expert here. Okay, so now we've got a nice clean line to be able to cut along. Let's see if I've got a sharp X-Acto knife for this week. Sure do. Look at that. That's beautiful. And now we've got a relatively clean piece of foam core that all of our electronics fit in. Now, let's try and make that so we have a actual box to fit this in. So this time I'm going to do an actual measurement. And I roughly need, let's say, 1.5 inches to be comfortable. 1.5 inches of foam core. So we'll make a mark. Add 1.5 inches here. Now I don't know how much foam core I actually need. So I'm actually just going to roughly cut out what I would call a blank. And then I can trim it down from there. So let's go ahead and cut that initial blank, just like that. And now we have some idea of what we have left. So let's put some sides on this. Now, I'm mating up the sides here, just like you'd expect, and you can actually just lay it over the top just like that to get the exact size you need. We'll need 2 of these, and then we'll have to measure for the next ones. Do the same here, and I might not have enough material, but that might be fine, depending on your overall design. And obviously I'm starting with a box. You might not need a front plate. We're going to go ahead and secure these to the sides, and then we need one for the front. So this is where the hot glue gun comes in. So we can put a small bead of hot glue right along the edge that we're going to make contact. And we want to work relatively fast, because if we don't, then the hot glue will cool down and therefore become solid and not sticky anymore. And you can run your finger along the edge there. And then let's go ahead and get this other side secured. Come on. Looks like the factory edge was a little rough on this one, but that's fine. Once it dries, it'll be secure enough. It's not like this is actually going to be a full-on combat robot. This is just a prototype for us to get the sizing idea that we need and what we might need for individual plates. Okay, that's bowed out a little bit. All right, so you can see that we're kind of bowed out here a little bit, and we can fix that after we go ahead and secure the back to this, because this will have kind of a factory edge to it then. So we'll go ahead and do a quick setup here, just like that. And we'll go ahead and cut. All right, so now that we've got the back cut out here, we'll just go ahead and line this up. We'll do another bead of glue around the edges. And that's the cool thing about working with hot glue is it sets up very fast. I don't think I've ever done any significant videos on me making RC planes, but this is the same material I use to make RC planes. Ha! See what I mean? That is very hot glue. Now I gotta wait for that to dry and I'll hold it in place for a moment here. And once it gets cool enough, what I'll do is I'll run my finger along the edge here, risking burns again, to get a nice clean bead. And there we go. Now we've got an enclosure that fits all of our electronics. And even this is a little large. This would be about the size you would need for actually incorporating a brushless electric motor in here. But now that we see what size we have, we can go ahead and consider this for our pusher design. So since we have so much extra material right in here, we can create, say, a 45-degree edge. Now, in most instances, I would have cut that 45 before attaching these sides, and that is just because I'm not a smart man, and we knew that already. So what we'll do is we'll go ahead and measure back. We know this is 1.5 inches. So if we do an 1.5 inches back, that'll create a perfect 45-degree angle, or we hope. We'll give that a try. Now these don't have to be perfect. This is mostly for visualization and initial measurements. When you go to make the actual final product, the actual aluminum or steel or whatever you choose for your material, you will want a better blank to be able to measure off of. However, this will give you an idea of the initial size requirements. As needed for this. Now let's take a look again. Now the one thing we're missing in here is the battery, so I have to leave room for that, and we might as well pull one in. Now we were doing these 2-cell, no, take that back. We weren't doing these 2-cell. These are my batteries. Let's forget about those. Let's pull in the 2-cell batteries that I recommended for you guys. That fits in there beautifully. Now this doesn't include the mounts that are going to be required, and there's a lot of different ways to do that. I'll walk through the potential hardware here next time. But while we're at it, let's go ahead and add that front plate and then consider what it's going to be like to close this up. And then we'll go from there. So now with a physical piece of foam here, we don't have to worry about measuring or even calculating what it's going to be. We can just go ahead and place it on a piece of foam, draw out what's needed, and I'm feeling underneath to make sure that I'm coming all the way up to that top. Okay, and once again, I'm going to use my angle here to be able to get a nice clean piece of foam. Okay. Go ahead and cut that out. And I can already see that I did not cut those angles perfectly. But you can also see that that is a complete wedge there. It doesn't come down and touch exactly to the ground. But you wouldn't expect to be able to with, what, 1/8 inch piece of foam? Nope, take that back. It's almost 1/4 inch of foam. So your material for your front wedge, unless you are going to make it out of some form of plastic, which you can do. If you do that, you're going to want to bevel that edge. You're going to want to make it so that it makes full contact with the ground. And I'll get into why that is sometime in the future. But just trust me, that is something you want to do. But this will give you some idea of the sizing requirements. Now, there's 2 ways you can do this, and I would suggest that we're going to go ahead and glue one side of this so that we can kind of lift up to get all the materials in there. So let's go ahead and hot glue this edge. The interesting thing about doing this as well is you can kind of get an idea of the physical interactions that are required for assembly of the final robot, and also what it's going to be like to mess with the robot in terms of putting the electronics in and out of it, because you're not going to build a robot to be one homogeneous system. You're going to want to be able to change out your parts. You got to pull the battery out. The motors are going to have to be changed out because they're not impervious to hits. And then, you know, wheels and armor and everything else. So when you're building this, and again, you don't necessarily have to build this. You can build another form of this. You can make it thinner. You can do whatever you feel like. Imagination is the key. But when initially putting together a design, build something out of foam. Look at how little foam I use just for the test and just for this prototype. Doesn't take very much, and this whole sheet's $1. Watch BattleBots, watch some of my videos, see what the other robots are kind of like, especially in the league that you're going to be participating in, and then you can kind of figure out how you're going to build to adapt to them. Don't necessarily think about your ultimate robot design in your head. Think about what you're going to be fighting and adapt to that. Now, even for me, this is a little tall for a wedge bot. I would want this a little more, little shorter, maybe a little longer with a more shallow wedge. But this works for an initial prototype. And see, now that that's dry, we can kind of bend that up away. And now we can fit the electronics in again. And now what I'm going to do is use some tape to finish securing this right here. We'll use my old friend, the handyman's secret weapon again. And we'll just close that down. That way it's more of a temporary connection. Okay. So obviously I'd be putting the motors out of the sides. As we look into potential mounting systems in the future, that will either be integrated or built in-house, and I'll show you what that takes. That'll probably be an episode unto itself. But let's go ahead and dump this stuff out, see if we can pull it out of this opening. That was the big question. Yep. You wouldn't necessarily have to have this on a hinge or even be removable. So this could be attached to the robot itself via, you know, epoxy or rivets or screws or whatever, the wedge wouldn't have to be a separate part. It could be part of the whole. So now we've got just this opening to cover. Now that is a big feature of most of these robots. If you look at even the kits, those are usually closed with some sort of polycarb or acrylic or something that you can see through. And the reason that is because these ESCs give off a light to tell you that they're functional, and the receiver also has a light to show you that it's operational. And then, you know, because we're not running a brushless motor of any sort, you're not having an audible cue that it's up and running. So you're going to need that visual cue to know that your robot is operational. So because you're going to need a section of acrylic here, that needs to be a separate piece. You're going to need attachment points. Again, for right now, we're going to simulate that by using some duct tape. So let's go ahead and line this up to get an idea of how much material we're going to need. And you might not be able to see, but I'm actually using the edge of the wedge that I created as a stopping point so that the top of the robot will actually be set up to be closed essentially. So let's go ahead and get that cut. All right, so that is the final enclosure right there. So again, we can put all the electronics in. Including our little antennas. And along with the battery, which we'll stuff in this corner. Plenty of extra space. And then go ahead and close that up. And actually, surprisingly, I have a ton of extra room. You might be able to hear the shifting of all the electronics in there, which is fine, but I can almost fit 3 fingers wide inside that opening, essentially all the way up to the front of the wedge. So that is a lot of extra space. Now that might be necessary for being able to put the mounting brackets in, or we might be able to make a second prototype that lowers this down a little bit so we take advantage of that space. Right now, I'm not going to do that. This is really just a demonstration of this kind of process. That is for you guys to decide. And with this, I'm putting up a challenge. So I want to see you guys create one of these. I know several of you are putting together some of your electronics and doing the initial tests. You can do the exact same thing with this as you did with the platform. All you need to do is punch a hole and tape in your motors, and you could make this a functional robot just like we did the platform the last time. Doesn't have to be perfect, just needs to run and demonstrate. And you can start getting critiques and getting an idea of what it's going to take to truly build the robot as a complete kit. But with that, that is where we're going to draw it to a close for episode 3 of So You Want to Build a Combat Robot? We are going to pick this back up next time with turning this into a actual functional, probably aluminum sheet metal and aluminum square stock or bar stock robot. But some of the other aspects of this will be actually acquiring the necessary parts. I have some in-house, but I'll probably order some brand new to show you guys the process. You might see from some of my other videos that I don't tend to rely on finger tech equipment very often, although I've started doing that more for some of my higher end robots. And I might recommend for some of you guys that the hubs and wheels for your first robot come from those guys, just because they are nice and clean and functional, and they do exactly what they are set out to do. But everything else, and I do mean everything, can be built in-house, with the exception of the electronics that you have here, and possibly the wheels and hubs, unless you've got equipment like I do in the shop, and some of you do. If any of you want to see a more in-depth construction process of 3D printed hubs or aluminum hubs like I put on Bad Touch, please ask in the comments. I'm more than happy to do an episode on that. So that's the end of this one. I will catch you guys next time for the continuation of this series and the materials and initial construction process of turning a essentially paper prototype into a functional robot. It'll probably be 2 or 3 more episodes before we actually have a functional pusher bot to test out in the arena. So you guys be safe out there, and I will see you next time.